So for a problem like this, it was suggested that I'd use integration by parts. I tried it at the stage of the problem, but it ended up with a very long process. So what we can do is turn this into something simpler before using the said method. So we can take one half out of both of these terms, giving us this. Now we can further separate both of these factors, and we have to keep in mind that they should retain their roots. Now this 1 over square root of 2 is just a constant. We can bring it out of the integrand. At the same time, we can perform this operation, giving us 2x plus 1 all over x. Now we can separate both the numerator and the denominator, and from here we can further integrate using trig sub. We let 2x be equal to tangent squared theta. Getting tangent alone, we take the square root of both sides, giving us square root of 2x. Now solving for x, we can divide both sides by 2. We get x is equal to 1/2 tangent squared theta, which is also equal to tangent squared theta all over 2. Differentiating both sides, we get 1/2 times 2 times tangent theta secant squared theta d theta. Simplifying things further, we get tangent theta secant squared theta d theta. From that, we can now give definition to our right triangle. So with our right triangle, its angle is set here, and with the definition of tangent being opposite over adjacent, we can say that this opposite leg is equal to square root of 2x. Meanwhile, this adjacent leg is equal to 1. Solving for the hypotenuse leg, we can use Pythagorean theorem to arrive at the square root of 2x plus 1. Going back to our integral, we can plug in our values for x, 2x, and dx. Now what I notice here is that this fraction, its denominator is also a fraction, so we can rearrange it like this. Now the square root of 2, we can bring it out of the integral. At the same time, I turn this tangent squared theta plus 1, turning it into secant squared theta. So simplifying things, we get this. The secant squared theta, I took the square root of it, giving us secant theta, and also this tangent squared theta, I took the square root of this, giving us tangent theta. Simplifying things, we get the integral of secant cubed theta d theta. Now we can use integration by parts by splitting this into secant theta times secant squared theta d theta. We let u be secant theta. Differentiating both sides, we get secant theta tan theta d theta, and what's left will be our dv, which is secant squared theta d theta. Integrating both sides, we get v is equal to tan theta. Now with our integration by parts, we have a certain formula that should be followed. With the first term of the formula being the product of u and v, we get secant theta tan theta minus by the integral of the product of v du. So tan secant theta tan theta d theta. So simplifying further, we get secant theta tan theta minus the integral of secant theta tan squared theta d theta. Now we can turn tangent squared theta into secant squared theta minus 1. We can multiply this to both of these terms, giving us this. Now from here, we can integrate both of these individually, so we get this. And keep in mind that a negative multiplied by a negative will give us a positive, and this secant cubed theta d theta will remain negative. Now from here, what I notice is that what we're trying to integrate is just secant cubed theta d theta, and we also have secant cubed theta d theta, but we have it's negative, so we can transpose this to the other side, giving us 2 integral secant cubed theta d theta. We can add both of these together, giving us 2 times the integral of secant cubed theta d theta. Solving for this, we can divide both sides by 2, giving us this. Now what's left to do is integrate secant theta d theta. Now this is a known integral, which is just the ln of absolute value of secant theta plus tangent theta. From here, we have to return everything back in terms of x. So from our right triangle earlier, and with the definition of secant being hypotenuse over adjacent and tangent being opposite over adjacent, we can say that our secant theta is equal to square root of 2x plus 1, while our tangent theta is equal to square root of 2x. Same goes for these two. Now we can multiply these, giving us this term. And what I did is the square root of 2 divided by 2 will give us a square root of 2 in the denominator. And since all of these are of the same power, we can combine them, and what's left to do is multiply this x to these terms, giving us this, so plus the constant in the end.